Hey everyone, welcome back to the Flatbuffers series. In today's video, we are diving into nested tables in Flatbuffers, and we will be doing it with real-world examples. By the end of this video, you'll understand how to model relationship in your data, like an employee having an address or a department, using Flatbuffers. So let's jump in. Before we get started with the code, let's quickly recap. Flatbuffer let us define structured data using schema files. So far, we have seen simple fact structure, but real world data isn't always that simple. Sometimes one object contains another, like an employee having an address or a manager. That's where nested tables come in, allowing you to embed complex objects inside other. So let's say we have an employee schema or employee table. So it includes basic fields like ID, name, and age. But now we have also want to include address with fields like street, city, and zip code. So let's see how the schema looks like. So we have already created a IPS file with employee.ips extension, and this is how our schema looks. So if you can see, we have added an extra table. So this address table is a nested table, and it is being referenced to the employee table. So first we will be building this address table, and then we will be seeing how to set these particular attributes like street, city, and zip code. So this is a classic nested table structure. Now let's generate the Python classes for this. So for that, we will have to just go to this folder, cd fps, and then we will have to run this flat c python, and we have to give the name as employee.fps. So once we run this command, you can see under this APS folder, under this myApp section, so this address and employee py files have been generated in which we are having the class method defined for generating the object. Once we have generated this Python file, let's write the code to create an employee object along with their address. So let's begin with creating a Python script, and we will be naming it as employee. Okay, so initially we will be writing support plan buffers, to which we need, and then we'll be initializing the builder object. So right, so builder plan buffers dot builder with address size, which will eventually grow. Okay, so let's first create the address object. So for this, we are having three fields: street, city, and zip code. So let's create a string from there for them. So that can be done by creating a variable for each and creating those strings with the help of create string method. And street, uh, let's rename it to like something called Baker Street. Okay, so you can give any text. Similarly, city. So let's initialize it for all the three parameters. And here we'll be writing them. Okay, and last is the zip code. So that also can be created with the help of create string method. And let's give something called as ABC, so some random number. Okay, so after defining those variables, let's start building the actual object. So we start with address start build. For now, we'll be seeing some error, but after importing address pipeline, this error will go, but we will do it at last. Or let's do it first. So we just hover over it. So if you click on import them, so you can import this with the help of this. And now let's build the object. So here we get all the methods. So here we need add. Okay, okay, let us remove this. I think we had a wrong import. Okay, yeah. So if you can see here, we can have this add city, add street, and add zip code options in here. So after creating this, Yes, specify builder space, and in street we'll specify this variable. Similarly, we will be doing this step for zip code as well as city. So we'll just change the name from address, add city, copy this city, and here we'll put in add zip code. Okay, and we'll just find this variable here. Okay, now it's time to end this particular object. So for that, we'll specify address dot end. And that will be object in address hyphen obj. Okay, so now the object is created, and now let's write builder dot finish and specify this address underscore object over here. Okay, this finalizes the flag buffer, and address dot underscore object is the offset returned by address dot address and builder method. And this call tells the flat buffer builder to set the root table to the object at address underscore obj. And one more thing, so we'll be taking the same bar one. Okay, and here we'll put builder dot output. Okay, okay. This extracts the actual byte array from the builder. This buff1 is what we use to store, send over the network, or read data back from. Okay, so in this way, we have created the address object, and now it's time to create the employee. So for that, we have this particular name variables. For employee, we need to specify the name string. For that, we will be using name, and here we have builder dot create string, and let's specify the name. So we will be specifying Adam. Okay, and let's start. So what we can do is we can copy this particular, because this is the same object, and we'll just replace this name. So in the last session, we have seen that we also have an employee, a person's object, which with the similar attributes. So what we'll do is we'll just rename this with employee. Otherwise, you can write the code as well. Okay, employee start. So we have to import this name as well. And we will rename this person's. We'll replace this person in place, and we'll write employee. If you can see in employee also, if you see this employee ABS file, there is an ID, name, and age. And we can say ID, name, and age. So we have specified the ID, like suppose let's change this to something, and age we can make it as 56, and the name string is coming from here. And so again, we will end this object, and we will be taking this in employee.object underscore object. Again, similarly, we'll copy this file, these two lines, and we'll finish the employee object as well. So just for naming convention, now the buff we'll be creating, it is named as buff2. So you might have noticed how we created the nested table address before adding it to the main table. And this is important as flat buffers are always built from inside. So now let's read the data back and print it. Let's write the code for reading data from both the buffs that we have created. So for reading the data, we will have to create like two lines of code. So let me write it first and then we'll explain. So address dot, I guess spelling is wrong. And here we have to call the get root as address. We have to pass the object. So buff1 is the variable where the byte array is stored for address. So we'll be specifying it as buff1 0. And similarly, we'll copy this line for employee. So here we'll write EMP, and here we'll write employee. So it's similar. We just have to change the get root method. Okay, and here we have to specify the buff second object which holds the employee data. Okay, so yeah, so these lines are used to read a flat buffer employee object from the serialized byte buffer, that is buff1 and buff2. And let us break it down. So buff2, if you see, it's a byte or byte array object containing the serialized flat buffer data for employee. And employee.employee, this accesses the generated Python class, uh, which is auto-generated by the flatc in our FBS file, and get root as employee. This is a static method provided in the generated code. So it reads the root table, in this case, employee, and from the buffer starting at byte offset 0. It returns an instance of employee.employee, which give you access to all the data. So now to print, just we have to specify print, and we'll be printing all the parameters. So let's specify those. So for first, we are printing employee.id. So if you can see here, automatically it pops up. And we just have to use it. Okay. So similarly, we just copy it. Let's write it down. There are 6 attributes. If you see this employee.fbs file, street, city, zip code, ID, name, age, and here address object is being passed. So first is ID. So we have printed ID. Second is name of the employee. Third is the age. Let's have a semicolon for each of them. Okay. So let's print one more line, which is saying this is print. This is the employee data. Yeah. And secondly, let's print out the address data for that employee. So here we'll say address data is as follow. And we'll just change this to street, city, and zip code. City and zip code. And now we again make this particular thing and we'll change this. So this is street. So addr dot street. Then addr dot city. So this will auto populate. We just have to add the right object in here. And here this is zip code. Okay. So now we can see. So if you see the script, we have initialized the builder object in here, and then we have specified the strings for street, city, zip code. Then we have built the child object, that is address object, and we have taken that particular output in buff1 byte object, byte array of output, and then we have created the employee object for which we needed a string name, and these are the details which are like integer type. So we have directly specified in here ID and age, and we have passed in this address object in here. Okay, okay. So let's see. We have not passed the address object, so let's pass that as well. Okay, so this was the major. So here we have to add address. Just a minute, we'll add it. So there would be a method called as employee add address. Okay, and here we have to specify builder dot, and we have to specify builder comma this object. Okay, so that's it. Yeah. So now the address is also part of employee. Okay, and now we are having two object, address object and employee object, for which we are printing the data. So let's print the data and see. Now, if you can see, employee data is as follows. The ID is 28, name and age. Okay, so some mistake in here. Let's see. Okay, so here we have not called the method properly. So in here we have to call name, and here we have to call as age. Okay, and one more thing, if you can see here, address data is printed, but there is an extra B. So if we have seen in the last lecture, for the person's object, we need to decode it. So we'll just add this particular code to street. city and zip code and as well as name. Okay. And we will add the semicolons here. Okay. Forgot to add the semicolon. Okay. So after adding this, let's print it. Now, if you try to print this, there is some error. Let's see what it is. Employer name. Okay. There is one more. No. Okay. And here also we need to do this particular extra. Yeah, the brackets were missing. So let's run it. Now, if you can see here, employee data is as follow. ID, name. Okay, name is getting wrong. So what is happening? Name is printed as employee.name and name is printed as the name should be printed as Adam. Okay, and the streets and everything is placed. Okay, name is printed as London. Let me see what happened. So here, we have specified the string. We have passed it here. Buff to employee.name. Okay, this is perfectly fine. Let us run this once again and see what happens. Okay, so employee data is as follows. Name, employee.name. It should get printed. Okay, there might be some error, but you can print the other parameters in this way. So we can see this particular thing in the next lecture, that why this name is not getting printed, and we'll follow up on this. So this is how we decode and create a nested structure in flat buffer. And flat buffers keeps things fast and efficient, even with nested relationship. So nested table are extremely useful when your data contains logical grouping of sub-object for employee, for example, that an employee that might be having multiple addresses, a product that might be having different specification, a user which might be having different profile or setting table. So instead of flattening the data, nest it logically for clarity, maintainability, and performance. And yeah, that's it. So we have just built and read a nested file buffer structure using an employee address example. If this has helped clarify things, make sure to like this video and drop your questions or any flat buffer related challenges in this comment section. And yeah, lastly, subscribe to the channel because next up we are exploring vectors and how to handle arrays of nested tables. So thanks for watching and keep flattening those buffers.